Hello guys, today we'll be discussing about turbo machines, the various classifications involved in it and the general principal parts. Turbo machine. Turbo machine is a device in which energy transfer occurs between the floating fluid and the rotating element due to dynamic action, which results in change in pressure and momentum of the fluid. Generally in turbo machines, mechanical energy is transferred in or out of the system in a steady flow process. The principal components of a turbo machine. They are rotor, stator, shaft and housing. Rotor. It's an element of the turbo machine fixed with blades. The energy transfer occurs between the fluid and the rotating element due to momentum exchange between them. Stator. It's a stationary element fixed on the casing to control or regulate the flow direction of the flowing fluid. Shaft. It is an integral part of the turbo machine. The energy flow occurs from or to the turbo machine through the shaft only. Finally, housing. It's a form of the covering. It forms the covering of the turbo machine, which makes the working fluid to flow in the space without splashing towards the surrounding. Here we have a general outlook of the cross section of a turbo machine. Turbo machine can be characterized on the basis of nature of flow through the passage of rotor. They are axial flow turbo machines, radial flow turbo machines and mixed flow turbo machines. Axial flow turbo machines. When the path of flow is wholly or mainly in parallel to the axis of rotation, it is termed as axial flow turbo machines. Here we have an example of Kaplan turbine. Radial flow turbo machine. When the path of flow is wholly or mainly in a plane perpendicular to the axis of rotation, it is termed as radial flow turbines. Example, centrifugal pumps. Finally, mixed flow turbines. When the flow is partly axial and partly radial, the device is termed as mixed flow turbines. Example, Francis turbine. Turbo machines can again be classified on the basis of whether the pressure change are absent or present respectively. They are impulse type turbines and reaction type turbines. Impulse type turbines. There is no pressure change of the fluid or gas in the turbine blade. It does not require a pressure casement around the rotor. All the pressure drop takes place in the stationary blades before reaching the turbine. The fluid pressure head is changed to velocity head by accelerating the fluid with a nozzle. Newton's second law describes the transfer of energy. Example, Pelton wheel. Reaction turbine. Reaction turbine develops torque by reacting to the gas or fluid pressure. The pressure of the gas or fluid changes as it passes through the turbine rotor blades. A pressure casement is needed to contain the working fluid. Example, Francis turbine. In this case, Newton's third law describes the transfer of energy. Here we have the impulse turbine and reaction turbine differentiated with their respective graphs too. Finally, based on energy transfer, energy absorption turbo machines, energy generating turbo machines and energy transmitting turbo machines. Energy absorbing turbo machines. Turbo machines that increase the rate of fluid flow through them is termed as energy absorbing turbo machines. Example, pumps and propellers. These are propellers used in jets. Energy generating turbo machines. Turbo machines that generate or produce energy by utilizing the energy of the fluid supplied to it is termed as energy generating turbo machines. Example, steam turbines. This is a turbine generator systems which use steam turbine to generate electricity. Energy transmitting turbines. Turbo machine which transmits energy from the device to the drive shaft is termed as energy transmitting turbo machines. Example, torque converters. Thank you.